Okay. In the previous class, we discussed the concept learning, and one of which is research algorithms. Okay. We discussed this case. Okay. General to specific search method we discussed. We discussed the algorithm and the parts of. Yesterday we discussed this topic. Okay. This is the approach we should take to solve this problem, and try to understand this concept. Okay. So now two more algorithms are there. One is specific to general search and a candidate elimination algorithm. These are similar to our general to specific search method. Okay. So I think it is better to first study the general to specific search method. This problem. Okay. Then after the doubts, or after you are familiar with this algorithm, then we can study the next algorithms. Okay. Else it will be very difficult to understand these topics. Okay. These two topics. So I think it is better to take this after some classes. Okay. These two algorithms I will take after some classes. Okay. Okay. So anyway, we discussed this one. Then remaining is specific to general algorithm. This is similar to general to specific. There is an initialization step. Then after that, for a positive instance, I want to do here. Okay. If it's a positive instance, I want to do these tasks. Okay. Then for a negative instance, I want to do this task. So a problem also will be there. I think I told already. I will discuss it in the after some classes. Okay. After some classes, because no need to create a confusion now. Okay. First you study the specific search method clearly. Then we can study these two algorithms. That will be better. This is candidate elimination algorithm. It's a combination of both the methods. Okay. It's a combination of general to specific and specific to general. So this is also somewhat complicated. Its problem is somewhat complicated. Anyway, I will discuss this topic also after some classes. Okay. That will be good for you. Okay. Next, I'm taking another topic, and this is and machine learning, and this next learning. Okay. This topic you already studied in our soft computing in our previous semester machine learning. We studied neural network and backpropagation learning. Okay. So that topic also we want to study here. Okay. So just I am moving very fast discussing the concepts. Okay. Okay. So this is called connectionist learning. Okay. Connectionist learning. Okay. So basically what is connectionist learning? The neural network learning using the neural network. It is called deep learning. Okay. Deep learning connectionist learning method. Okay. So here we want to discuss the Bayesian learning also. Okay. So what is connectionist learning? What is connectionist learning? It is a biological inspired model of artificial neural network. Okay. It's an artificial neural network based method. We know what is an artificial neuron. It consists of collection of artificial neurons. What is an artificial neuron? It's a mathematical model of a neuron. Okay. This collection of neurons can be trained to perform a task. Okay. Okay. So this is about the connections learning. Then which type of task it performed. We can use connection list or for performing this type of task: classification, pattern recognition, prediction. Okay, you know what is prediction, what is classification, what is patternation now. Okay, so I'm not discussing much more about this. What is classification? Decide in the category in which an input belongs. Okay, for image classification. Next is pattern recognition. I want to identify a particular in the input. Next, prediction. I want to predict the future. For example, I want to predict the COVID growth rate, etc. Okay, weather forecast. It is a prediction. Then optimization is another application. Okay, that is finding the best solutions to a problem. Finding the best solutions to a problem. That is called optimization. Another is noise filtering. Okay, noise filtering also is an application. That is separating from background, factoring out irrelevant components of a signal. These are the applications of neural network or connections models. Okay. Now, we know what is an artificial neural network. Okay, we know what is an ANN. Okay, this is a simple model of ANN. There are inputs and weight. Okay, by changing the values in the weight, a network always learns. Okay, always learns using by changing the weight. Okay, a network learns using the change in weight. Okay, so in the previous terms we studied that concepts. We discussed algorithms also. Okay, the same concept. Okay, next, then this is the net input. The net input from different, here x1, x2, etc., xn are different neurons, and the net input is sigma xi wi. It is given to the output neuron. What output neuron will do? It will calculate the uh, it will calculate f of net. Then it will calculate the it will apply the activation function on the net input. Then I will get the final output. So next, so which are the components in it? Input signals. Okay, input signal xi. Then weight. Okay, so this is very important. Learning is performed by changing. Okay, learning is performed by changing the weights. Okay, okay. Uh, Next is bias. We already know what bias. What is the use of a bias? Bias. What is meant by bias? Bias means an input neuron whose input is on. This is called a bias neuron. This is a bias neuron. An input neuron whose input is always one. This type of neuron is called a bias neuron. And bias weight means weight corresponding to that bias neuron is called the bias weight. Another component is net input. Net input. So we know this is sigma xi into wi. That is input multiplied by the corresponding weight. Summation. Okay, the summation of all inputs multiply its corresponding weight is called then is the net input. Next important component is threshold function or activation function. What is activation function? What is the use of activation function? Used to find the output of a neuron. Okay, again, will this is a neuron. This neuron calculate the net input to the coming to the neuron, then apply an activation function over it to get the final output. Okay, so in previous sum you already studied. That's why I'm going fastly. Okay. So this is called threshold function or activation functions. There are different activation functions. This function computes. What is an activation function? Activation function is a function it compute the final output of a neuron. It is used to compute the final output of a neuron. Various types of activation functions are sigmoidal function. Sigmoidal bipolar case is the binary sigmoidal and bipolar sigmoidal. Similarly, linear is there, and different activation functions are there. Okay, which are the what is meant for activation function? Linear activation function is like, okay, this is a linear activation function. Anyway, we studied different activation functions in the previous semester, so please study that topic. Okay, I'm not discussing this again because it is already studied. Please the previous some notes, sigmoidal activation functions, linear activation functions, step functions. There are different types of activation functions. We discussed that in the previous sums. Please refer that node, that notes. Okay. Now, these are local properties. These are called the local components of a neural network. The above are called local components. Okay, which are the local components? Input signal, weight, bias, net input, threshold. These are called the local components of a neural network. Then which are the global property or global components? The network topology. Okay, the network topology means in which way the network is connected. Sometimes it may be feed forward network, sometimes it will be backward back propagation network, sometimes it will be a single layer network, etc. These are called network topology. Okay, next, learning algorithm. Various algorithms can be used to train the network. Okay, just to refer our previous semesters, hub network is a learning algorithm. Perceptron training algorithm. Next is Adalin training algorithm. Next is backpropagation training algorithm. Okay, backpropagation network algorithm. So these are different learning algorithms used in a neural network. So this is also called a global property. Okay, this is also global property. Okay, so what are the global properties of a artificial neural network? One is the network topology. Second, the learning algorithm we are using. Okay, so next, another is encoding scheme. Third one is encoding scheme. Interpretation placed on the data to the network, result of processing. Okay, so uh, interpretation placed on the data to the network. Okay, that is which data we are applying to the network and what type of the result we are getting. That is called the encoding scheme. Okay, this is also a global problem. Sometimes in the exam they may ask which are the different properties of network. So there are local properties and there are global properties. Basically, you have an idea about the neural network. So what are the which are the local anyone? Vishnu, which local properties? That is input signals, weights, bias, net input, threshold function, etc. Threshold functions. Then global problems, there are three things. One is network topology, feed forward, backward, single layer, multi-layer, etc. Learning algorithm. Which learning algorithm we will use in a network? Okay. Okay. So this is hub network, perceptron training, DALIN, backpropagation. Okay. Then encoding scheme. Which type of input we are applying? Example, sometimes we will apply bipolar data. Some will apply the input will be in binary format. Okay. So some other type of input can be applied. Anyway, what type of input we are applying and what will be the result of processing? What type of result? That is about the encoding scheme. This is also a global property. Okay. Okay. Next, we are moving to the perceptron. Okay. Next, we are moving to the perceptron. Okay. 1 minute. Next, we are moving to the perceptron. So, what is perceptron learning rule? You know what is a perceptron? Okay. So, perceptron means what is perception? Ability of a system to recognize something. Okay, that is perception basically. Basically, we are humans. We having the perception capabilities. We can understand the sound. We can understand the image, an image, etc., etc. Okay. So, but the computer machine, we need to give some intelligence to recognize these type of things. Okay. So, what is perceptron? Show the architecture. Okay, perceptron learning rule is there. What is perceptron learning rule? Perceptron training rule is there. Okay, perceptron rule means in the previous semester we studied that topic. Okay, okay. So please refer that topic. What is perceptron and what is perceptron learning rule? Okay, so this is I studied it in S5 and S7. Okay, in the two sems we studied the same topic. There is a network architecture, and we want to study how learning is performed. Okay, so please use the same notes. I'm not discussing it again. Okay, uh, okay, that is perceptron and perceptron learning rule. Then now we are going to the backpropagation network and learning. Okay, backpropagation network and the learning. Okay, so this is the architecture. In this semester, we want to study this method. We don't want to study other algo or network learning algorithms. We just want to focus this algorithm and concept only. Okay, backpropagation network and learning only. Okay, so now this is the architecture of backpropagation network. Several times this question in the university exams. Okay, so this is the architecture of a backpropagation network. So which are the different components of this network? This is input neurons. Okay, these are input neurons. Then we will apply the input to here. Okay, so it is the term used is X, capital X or small, and this is called a hidden layer. Okay, Z1, Z2, etc. ZJ, Z. Okay. So there is a hidden layer. Okay, there is a hidden layer, Z. Okay, Z. So another is the output layer. This is an output layer. Okay, Y, it is termed as Y. Okay, so Now you can note three layers are there. One is the input layer, next is the hidden layer, then is the output. Then another important thing is between the layers. For example, if you consider this one and this one, okay. Also you can note here is a neuron with the input always one. This is called biased neuron. Okay. You can note here this is the biased neuron. The input is always one. Similarly, here also biased neuron is attached. Okay. Here also a biased neuron is. Note that. Then another is the weight. Between the layers there is a weight. For example, between the input layer and the hidden layer Z, there is a weight value V. How it is named? This is neuron Zj. Then the weight is Vij. Okay, then the weight is V. You already know this concept. Okay, so Vij. Okay, the naming convention used to given weight. This is ith neuron to jth neuron. Then the weight is here we are using a weight V. Okay, so it is V1j. Okay, V1. This is x1 neuron and this is zj neuron. So the weight is V1j. Okay, in general Vij. Okay, in this way different weights are given here. Different weight values are given. Already I told a network learns by changing the weights. A network learning algorithm always adjust the weight. Okay, this variable weight to learn. Okay, so backpropagation network learning algorithm also do the same. Okay, we can discuss that in the algorithm part. Next, another component is sorry. Another is this is also a connection from the hidden layer to the output layer. So this also having a weight. Okay, it is here the W weight is assigned. W weight is assigned. So Wij. What is the meaning of Wij? Weight between the ith neuron in the hidden layer and put neuron J. That is Wij. Similarly, weight variable is attached between in this way. For example, if you consider this link, okay, then it is P. This is Pth neuron. This is kth neuron. Then what will be the weight? Wp. Okay. Wp. Okay. In this way, different weight variables are attached. Okay. So this is about the weight. Then we already discussed. This is an input neuron to the. This is a bias neuron. Bias neuron is a neuron with input 1, and it is attached to the hidden layer. Similarly, one input neuron is attached to the output layer also. Okay, output layer also. This is about the network, and so final. Okay. Now this is the final layer. Okay. Which is the final layer? This is the final layer. So final, the basic concept is we will apply an input we will apply an input here. Then in the feed forward phase, we will calculate the final output coming from these neurons. Okay. So these are the output neurons. We will apply input from here. Here we will apply the input, then calculate the final output coming from these neurons. Okay. This is called the feed forward phase. Okay, that is, we will apply an input and we will calculate the output from these neurons, and finally we will calculate the output from the output layer neuron. This is called the feed forward. Then based on this, based on the output, it is compared with, here you can say, suppose this is y1 neuron and it produce an output one. Okay, it produce an output y1. This is compared with the target. Okay, this is compared with the target value. This is actually t1. This is t1. This neuron produce output y1. Okay, this neuron producing an output y1. So y1 is compared with the t1. If it is equal, no problem. What is y1? Y1 is output produced by after an input is applied. T1 is the target. Okay, target means you know what is target. Okay, so y1 is should be compared with, if it is equal, then we got the expected result. If it is not equal, then what we will do? We will change the, there are some errors occur. So we will recalculate the weight. Here also, based on that, we will recalculate the recalculate the weight here also. That is called the back propagation phase. Okay, if there is an error, we will use that error and try to correct that in these layers. That is called the back propagation learning, back propagation phase. That is, this error correction terms are back propagated. This, if there is an error here, then this the data is okay, we will study that while discussing the algorithm. Error terms are back propagated level by level. Okay, first it will be back propagated, then we will find the change in weight, then back propagated to here, then we will find the change in weight. That is called the back phase. And the last phase is weight updation phase. Based on the change in weight, we will calculate the final weight to get the count. That is called the back this phase. Okay, so we will apply an input, then we will calculate the final output. That is called the feed forward phase. Then we backwards error propagation. Okay, in order to correct it, we will propagate the error terms backward. That is called backward error propagation. Then finally we will update the weight between these neurons to get the correct output. Okay, this is the working of a propagation learning algorithm. Okay, now we want to discuss the back propagation learning algorithm. Okay, as I told you, a back neural network is a multi-layer feed. Okay, we can discuss in the next class. Okay, class we can discuss. Okay, okay, thank you. Mohammed Jasim Harris present ആണോ? Mohammed Jasim Harris. Okay, thank you.